Our next speaker today is Maja Mataric. She is the Chan Soon Chin Chaired and Distinguished Professor of Computer Science, Neuroscience, and Pediatrics at the University of Southern California, and the founding director of USC Robotics and Autonomous Systems Center. She has earned a number of distinctions. That's actually a really, really long list. But she's, among other things, a member of the American Academy for the Arts and Sciences and a recipient of the Presidential Award for Excellence in Science, Mathematics, Engineering, and Engineering Mentoring. She is a pioneer in the field of socially assistive robotics, and she's going to tell us about some of her incredible trajectory. She is also a co-founder of Embodied Incorporated. So let's welcome our next speaker.
Let me just make sure we have audio. It's absolutely wonderful to be here. It's wonderful to come back to one's alma mater, and when that alma mater is MIT, then one gets to be a part of this lineup of speakers. And for me, especially, I have to say, it's super special to be in the same lineup along with Tomas, who is gone, but I guilted him about this. Oh, no, he's there. Okay, great. Oh, thank you, Tomas. What a nice guy. I guilted him and he stayed. Okay, thank you, thank you. I have to say, I said I wouldn't say it, Tomas, but I'm gonna say it anyway. When I was a grad student, we were all so afraid of Tomas, because I just had this realization today that when I was a grad student, people like Tomas and Rod were young. But they didn't seem young to us. And they were scary, but especially Tomas. It was all configuration space, 24/7, wall-to-wall configuration space. Ooh, okay, so anyway. And Rod was infinitely tired all the time because he was pre-tenure and then slightly post-tenure. And he was just running around the world, raising money, traveling, and apparently raising a bit of hell as well, and controversy around trying to teach the world to think differently. And teaching us in the lab to think differently by example. And so those were some amazing lessons, not so much about being scary, but about thinking differently. And so it's just a huge honor for me to be in the same lineup with these two giants to me. Also very old, I might point out. Not me. I will not speak about my trajectory because I want to feel like I'm young, and I'll come back in a couple of decades to tell you about my trajectory. But we do have to go into the past a little bit. And so in my first days at the AI lab, which was a long time ago, but there was email. Email was young. It was young and exciting, and I remember when email was exciting. I just want to share that. It was like I got an email message. Okay, so I was just completely fresh from Kansas, in Kansas fashions, and I was talking to faculty in my very first days about what I was interested in, and I was talking to a very important person that was mentioned earlier today, but I will not name names, but this person was mentioned earlier today, and he's a very important professor. And so he asked me, what are you interested in? Because I was talking to potential future PhD advisors. And I said, oh, I'm interested in expert systems and neural networks. And he said, and I am quoting here. And I remember this, and I will not have anyone tell me that I made this up or dreamt it up. It's true. And he said, don't say expert systems, say knowledge-based systems. And as for neural networks, don't say it at all. So that's a quote. And so life lessons out of that, well, one is everyone gets it wrong sometimes, maybe. And so just do your thing. And that's a great, empowering thing that we all learned at MIT, which is do your thing. Just believe in the craziness and do it, and moreover, you have a responsibility to do it. Like somehow it's your job to do that crazy thing because you were trained to go and bang your head against the wall and go do it. And it's amazing training, and it's incredibly empowering with all the scars, but it's great. And also, I would like to think that being that weird student that was not a typical student back then taught me a lot about taking atypical students. So in my career, I've taken a lot of students based on their passion and commitment, less so than their necessarily pedigree and skills. And it has paid off amazingly. So my people have been amazing, and that too I have to thank MIT training for. Now, we're just gonna, one more year. I promise this is the last memory lane slide, but it's fun. First of all, look how much hair we all have. God, the hair. So Rod's lab was called the Mobot Lab, and we used to, among other things, we pushed ourselves in every possible way because Rod was a model. And we're like, hey, why don't we run the Boston Marathon? How bad can it be, So, a bunch of MIT nerds get together and train for the marathon, and we ran multiple marathons. It was amazing. There's a whole separate set of stories on that I will not tell. But we used to, of course, train along the Charles during the worst time of the year, and we would take turns talking to Rod. So now you have to imagine a bunch of nerds panting, straining in our really low-tech clothes that were soaking up the rain and the sleet and everything, but getting the opportunity to talk to Rod because he wasn't on a trip right then, and so I'm talking to Rod. And I say, any research advice for me? And he says, just have a good idea. No, have a great idea. And I thought, cool, that's like no pressure. So I said, well, how will I know if I had one? And he said, oh no, do good. That was profound advice. But it really was, because Rod was an amazing advisor. And one of the key ways in which he was an amazing advisor is not because he sat with me for hours and helped me do stuff. He did not. But he was a great advisor in the sense that he granted complete autonomy and provided the resources for us to pursue that autonomy. I had 20 robots. Who else had 20 robots? No one else did. Most of them never ran. Doesn't matter. The point is, he granted autonomy, and he maintained really high expectations. It was that great idea. Actually, I wasn't going to say this, but I will. I later, much, much later, like more recently, asked him, I said, well, did I have a great idea? And his answer was, well, you must have, because you finished. So, don't dig. But it was really also that peer group, that amazing peer group of folks. We were called the AI lab back then. We were not CSAIL yet, but it was, the AI folks and the CS folks. And that amazing peer group, that was the source of support and the feedback and the critique. And I still remember getting my first compliment from Paul Viola, and I still remember it because that guy never said anything nice to anybody but their work. And when he said one nice thing to me, I was like, oh, I have arrived. And so that was so important. And then the do good, I don't know what Rod meant with it. I mean, I'm sure now he'll say that he meant do good for the world. But that's how I took it. And it was really a compass. It was a compass for me for the rest of the time. And so that's what the rest of my talk is going to be about. And everyone's talking about doing good with AI now, because now we're all afraid about doing evil with AI. But for some of us, that's been a compass from day one. And one of the other great takeaways about MIT and what MIT is about. So that's what I want to tell you about. I want to tell you about doing good with AI. And for me, the inspiration has been this vast need and opportunity in human health and wellness, but also the fact that we're constantly, as a technology community, introducing technologies into the world without proper forethought and proper testing. We're using the world as our little test space, our little sandbox, except it's not little, and it's not a sandbox. And there's some really serious implications, and we're starting to discover those. And so we should have a bit more responsibility. And so for us, who have been kind of taught to do good, it's actually, for me, the big kind of the goal is to think about how we can develop these accessible, personalized, and adaptive technologies for care and wellness. And so that's what I've been doing for the last 20 years. I spent the first N years, less than 20, doing things that were more curiosity-driven, robot teams, distributed robotics, lots of stuff like that. But since then, I really, I wanted to tell my kids, 3, why I do what I do, not just what do I do, but why. And they don't care how publishable it is. They don't care how much money it brings. If you can answer the question to your kids about why what you're doing is worth it, then it probably is. If you can't, dig deeper. So that was a big lesson for me. What does it mean to do good? And so that's what I'm thinking about, is how, actually probably a better way to think about it is this slide. I just did the change a minute ago. I learned from the master. Rod is still hacking his slides. That's how it's done. But really, the goal is these human-machine interactions. For me, it's usually human-robot interactions, but it's also HCI, on how to develop these technologies. And they need to be personalized, because really for everyone, the way you can help them, whether you think about it as personalized medicine or personalized behavioral health, which is more the realm I'm in, it has to be personalized. One size does not fit all. And it's really a combination of care and training. So you can't just fix someone. They have to keep working at it lifelong. So how do you engage them in doing that? And then how do you make it delightful? Because otherwise people won't keep doing it. And that's how we formed this field of socially assistive robotics, along with my former peer and fellow Brian Scazzolati, who is now at Yale. The idea being developing machines that help people help themselves through social and not physical interaction. Nothing against physical interaction, but it's taking a while. Again, maybe in 20 years, but it's coming. There's some really interesting work in haptics, soft robotics that all come together eventually. But right now, we're focusing on the part where we're using data, so that's the quantified self, and we're using the coaching strategies, but what we're really doing is trying to understand how to provide motivation and companionship that drives behavior change. Obviously data-driven, obviously ML supported, but it's around that motivation and companionship. So, what does that really mean? So how do you help people help themselves? Well, we focus on improving and sustaining motivation, adherence to what you should be doing, and then grit, which is the ability to persevere through failure. And so there's modeling going on at many levels. So usually there's a behavioral phenomenon being modeled, then there's modeling the user, and then there's the learning, maybe some form of RL or something, which is personalizing. And so I'm just gonna go very quickly and tell you this field started about 20 years ago. And I'm not gonna play this video, but there's been a lot of evolution, starting in sort of single point studies all the way to leaving robots in homes for a month or more and getting a lot of data. And I just want to talk very briefly about problems worth doing and maybe problems not worth doing. And so there's a lot of interesting work going on now in affective computing. And we were interested in just scratching the surface on deception because we were interested in understanding when people are masking the problems that they're having. But then when we looked into deception, well, I found that an undergraduate in my lab could do deception detection based both on unsupervised and supervised, either way learning, so it wasn't that hard, with like 90% accuracy. So guess what? ML is really good at detecting lying. We humans are at 50% in general, and ML is at over 90. Is that good? I don't know, but it's a fact. So it's not really a hard problem, not really worth working on. On the other hand, engagement, understanding if the person that you are talking to, whether you're a robot or human, is actually engaged in that interaction, and how do you keep that interaction going? That's a really hard problem. It's personal, it's contextual, it's multimodal, fantastic. So that's an open problem. The other one, maybe not so much. So I want to give you some examples of the kinds of work that we do. So here's an example that bridges, well, neuroscience, developmental science, and computing. We were interested in helping babies develop better. So in order to do neural development, you have to do a lot of rehearsal and a lot of practice, right? How do you get a baby to practice a specific movement? Well, you can't. You can't tell them what to do. You can't tell anyone what to do, but especially not babies. So how did we do it? So with this, and you know, my students are amazing, right? So we used, in some sense, the probably mirror neuron-driven ability for babies to imitate what they see. But how do you get them to look in a particular place? Well, we used the model of salience of surprise, which works for adults. It's trained on adult data, what works for babies. That's because it's early vision. Nothing else works between adults and babies. Anyway, fascinating loop. We can predict where babies will look. We draw their attention to to a particular body part of the robot that moves in a particular way, and then with some probability they imitate. So we're basically virtually puppeteering babies through computational models. I love that because it does help their development. We were also looking at empathy, modeling empathy. Why do we care about empathy? There's kind of a shortage in the world, maybe you've noticed. So we're interested in having agents make users more empathetic. It's very easy to create a robot that looks empathetic. It's very easy to say things like, I know how you feel. But how do you induce empathy in another person? And so we worked on these robots that either tell stories or talk about themselves. And we, for example, discovered that you can predict empathy in a user by depending on how whiny the robot is. Spoiler, annoying, needy robots are actually capable of getting the most help from users. Who knew? I find them annoying. I didn't want to help them, but in general, the public was more interested. So there are all kinds of things we need to understand about human-machine interactions that are completely new. It's a whole new frontier. It's never happened. In all of our evolution, we've never interacted with intelligent machines. There's much to learn and to do carefully. I was compelled by the last talk. We too have been working for a long time on K-12 STEM and using technologies for STEM. And I just want to point out this one relatively recent result we have on tangible learning. You know how kids learn by touching things and moving around? Well, that's fundamental to our brains. And so now we added this idea of having a robot coach and augmented reality. And suddenly, by moving code blocks around in physical space and playing with other friends moving blocks around, like they were playing ball in the air, but no actual balls in the air, the kids were learning to code better because they were taking more chances. They were more willing to fail while they were playing, and therefore they were better coders at the other end. And so what do we do? Of course, we teach everybody to stare at a screen when they learn to code. Not good, but this is a great way to introduce tangible movement-based behavior and get better learning results. Speaking of learning results, just towards the end, I want to say that our largest discoveries in our work and the hardest work, and again, I'm so proud of my students, have been in working with populations with differences. So we work a lot with kids on the spectrum, looking at their behavior. You know, there's a line. If you've met one person on the spectrum, you've met exactly one person on the spectrum. So they are very unique in their constellation of symptoms and severities. But that's important because when you try to develop machine learning algorithms for users like that, then the other stuff is kind of easy. So there's some really interesting challenges in how you do socio-emotional engagement and learning with users on the spectrum. And so I won't play this. This is all on the web. Just to wrap it up, what we're doing now is actually we've deployed multiple studies in the dorms at USC where we finally have our convenience population become our target population. So we're working on systems that people use in real time to help, for example, students with ADHD study. We just did some LLM-driven cognitive behavioral therapy. Wouldn't you like to know if it's safe to do cognitive behavioral therapy with LLMs? Well, talk to me after the talk. Personalized mindfulness and biofeedback, and we're in all of that, and also doing some stuff with the Alzheimer's. In all of that, we're developing these small, low-cost, cheap robots so that we can deploy them at scale. So we can have studies that even NIH will fund, like with 50 and 100 users, as opposed to 2 or 3 with robots costing $7,000 and then falling apart in 3 weeks. So this is what our robots look like. They're really cute. They're really engaging. That's important. And the users are really responding. And so it's robotics because it's physically embodied, and everything this very simple embodiment does turns out to be extremely important to the user in real time. But it all loops back to MIT, so here I am at the USC hooding just a few weeks ago where I was giving a lab tour right after, so MIT regalia and the robots right now. But yeah, it's all that training and all of the good advice resulting in us trying to develop these well-designed human-machine interactions. And I think it's especially timely right now because there's a lot of AI coming out, and I'd love to see more of the amazing students focus their attention on human health and wellness. And with that, I'm going to stop and say a big thanks to my students, some of them shown there, my collaborators, our supporters, and then look at the timeline from 1990 to 2023, a smaller subset, but less hair again. But here we are. Thank you so much for including me today.